it going? For this section, what we're going to do is build the unit circle from scratch. So what I have here, I know you see it, there's a circle on top of the XY axis. This circle has radius of 1, so the length from the center out to the edge over here is 1 in every direction. And the first thing I want to do is divide this up into parts. Now, if you'll recall, the circle all the way around is 2 pi. So there are 2 pi radians in this circle, and we want to break this down into angles. So right here at the beginning, we have 0, and then remember all the way around is 2 pi. Well, halfway around, so half of 2 pi, remember, is pi. And then I say divide it into 4s. So if I divided this into 4 equal parts, you'll see you have 1, 2, 3, 4, right? And those are going to give us, well, half of pi is pi over 2. So at the top, we have pi over 2. That's our angle. And that's if you start in standard position and you go in the positive direction. So that angle is pi over 2. We've already talked about this one being pi. Now, if you count, that's 1 pi over 2. That's 2 pi over 2, which, of course, reduces to pi. This is 3 pi over 2 at the bottom. And then here we have 4 pi over 2, which, of course, is 2 pi. So you can count these again. Divide it into 4 equal parts. And because pi is over here, that means 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, and then we reduce to lowest terms. Now let's take the same circle and divide it into 8ths. So remember again, the top half is pi. And so if I divide this circle into 8ths, of course, we're going to have a mark where we start, and then 1, 2, 3, 4, 5, 6, 7, and then all the way back around is 8ths. Now that's not over 8, right? Because it's 2 pi all the way around. If we divide 2 pi by 8, we get pi over 4. So here we have 1 pi over 4. At the top we have 2 pi over 4, which we already know reduces to pi over 2. Then we have 3 pi over 4, 4 pi over 4, which is still pi, 5 pi over 4. At the bottom, this is 6 pi over 4, which reduces to 3 pi over 2. We know that. 7 pi over 4. And then over here, remember we started at 0. This is 8 pi over 4, which is 2 pi. Now, we already had pi over 2 pi, 3 pi over 2, and 2 pi. But now we've got a new pi over 4 in the middle, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Now let's take a look if we divide the entire circle into 6ths, which would give us pi over 3, right? 2 pi divided by 6 would give you pi over 3. Now again, if this is considered pi, and of course this is considered 0, always, and then you want to do thirds, you divide the top half into 3 and the bottom half into 3, and that gives us 6. So we have a mark here, a mark here, and a mark here. Those are entirely too close together. I don't want to get too hung up on that, but that's probably a little bit better, okay? And then I go down low and do the same thing, a mark here, and a mark here, and a mark here. Now, you notice what doesn't show up is the y-axis is not one of the third marks at all. So if I count, this is 1 pi over 3. I don't count here. This is 2 pi over 3. This is 3 pi over 3, which reduces to pi. This is 4 pi over 3. This is 5 pi over 3. Please do notice that I didn't mark down low. And this is 6 pi over 3, which we also know is 2 pi when we reduce it. And finally, we can divide a circle into 12ths. This will pick up some of the guys we already know, but we're going to do it anyway. Now, if I divide into 12ths, that means there's 6 across the top and 6 across the bottom. So that's going to give me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, one thing I want to point out, when you count the 12ths, which is every pi over 6, because again we're dividing a 2 pi by 12. What it doesn't include, I'm going to put this in red, is your over 4 marks. So right here doesn't count, right here doesn't count, right here is not one of your marks, and neither is this one of your marks. So I'm ignoring the red over 4s. So when you label all this at one time, you got to keep that in mind. But the 12ths are great because it names everything on your list. Watch this. I'm going to go back to black so you can see. So remember, you always start at 0. And this is 1 pi over 6. Don't count the red one. This is 2 pi over 6, which reduces to pi over 3. This is 3 pi over 6, which reduces to pi over 2. That's a 2. This is 4 pi over 6, which reduces to 2 pi over 3. This is 5 pi over 6. You know 6 pi over 6 just reduces to pi. 7 pi over 6. 8 pi over 6, which reduces to 4 pi over 3. 9 pi over 6 right here, which reduces to 3 pi over 2. 10 pi over 6, which is 5 pi over 3. And finally, 11 pi over 6. So if you can reduce a fraction to lowest terms, oh, and 12 pi over 6, which is 2 pi. If you can reduce a fraction to lowest terms, that takes care of almost every value on the unit circle that you're going to have to learn and memorize, except the over 4s. And if you remember, that was 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. What do you think? You can do this. So if I give you a blank unit circle, these are the marks you're going to have on the circle. And if you have to name the angles, which you will, again, watch me do this. So I start at 0. Remember the marks in the middle? Those are over 4s. We can do them first or we can do them last. Let's do them first and get it over with. So remember, this is 1 pi over 4. This is 2 pi over 4, which is pi over 2. This is 3 pi over 4. This is 4 pi over 4, which is pi. This is 5 pi over 4. I'm putting it in the wrong place. It's right there in the middle, y'all. Okay, let me erase just real quick. You catch up. Okay, this is 6 pi over 4, which reduces to 3 pi over 2. This is 7 pi over 4. And this is 8 pi over 4, which reduces to 2 pi, and that's all the way around. So notice I only put marks in the quarter marks. I'm ignoring these 2 little ones on each side of the quarter marks. Then you can use your over 6s to count everything else. So watch this. Okay, the only thing it leaves off is these over 4s in the middle. So this is 1 pi over 6. This is 2 pi over 6, but that reduces to pi over 3. Now you do count this one. This is 3 pi over 6, which reduces to pi over 2. This is 4 pi over 6, which reduces to 2 pi over 3. This is 5 pi over 6. You do count this one, which is 6 pi over 6, which reduces to pi. You have 7 pi over 6 right there. 8 pi over 6, which reduces to 4 pi over 3. 9 pi over 6 right here, which reduces to 3 pi over 2. 10 pi over 6, which reduces to 5 pi over 3. 11 pi over 6, and then 12 pi over 6, which is 2 pi. And that is every single angle on the unit circle. So my suggestion, count out the over 4s first. Remember, those don't use these 2 little marks on either side of the center. And then you start your over 6s, which count everything but the over 4s, which is right here in the center. It still counts the XY axis. Okay, notice, what if you have to do this in degrees? And you do, by the way. So how am I going to do this? We know it starts at 0 degrees. It ends all the way around at 360 degrees. Couple ways you can think about this. We've got 30 degrees going on right here. Again, you can do your 45s. That's the smart way to do it, is maybe this is 45 degrees plus 45 degrees is 90 degrees. Oh, not writing. Plus 90 degrees is 135 degrees. Plus 45 degrees is going to be 180 degrees. Plus 45 degrees is 225 degrees. That's this one, y'all. Plus 45 degrees is going to be, I have to think about that one, 270 degrees. Plus 45 degrees is going to be 315 degrees. Plus 45 degrees is 360. Sorry about the inking. I know it's not looking all that great. Now, these are 30 degrees away. It's just like the over 6s. So this is 30 degrees. Plus 30 more is 60 degrees. Plus 30 more is 90. We already have that one marked. Plus 30 more is 120. Plus 30 more is 150. Plus 30 more is 180. Plus 30 more is 210. Plus 30 more is 240. Plus 30 more is 270. Where you have that marked. And then 300 is 270 plus 30. And 300 plus 30 is 330. And 330 plus 30 is 360. So the same way I got the radians, I got the degrees, or you can do all the radians and convert it to degrees, remembering that pi is equal to 180. That works. So let me show you a completed unit. Well, no, we're not ready for that yet. I'm not going to show you a completed unit circle yet because we've got more to do. Hold on. Okay, folks, so now we have to start labeling points on our unit circle. So we have an angle, and if we draw it in standard position, remember you draw along the positive x-axis and then get your angle. I'm going to erase this angle in just a minute, but say we draw an angle, a pi over 3 angle, then you draw along the positive x-axis, then you draw up to pi over 3, and that's your angle of pi over 3. Remember, that was also 60 degrees, and so that's your 60-degree angle. So that's how this works. Now I'm going to erase that because that's not what I'm working on right now. What I'm working on right now is the points on your unit circle. So I'm really ignoring these angles right here, okay, and I'm thinking about these values on the unit circle. And if you'll remember, the unit circle, the formula for the unit circle is x squared plus y squared is equal to 1. So when we square our x value and we square our y value, it's going to equal to 1. Now, that also means our radius is 1 in each direction. So if I'm thinking about this as an xy axis, this point right over here, you know what it is. It's 1, 0. The x value is 1, the y value is 0. Considering the other side over here, that is negative 1, 0. Why? Because again, the radius of this circle is 1. The center right here is 0, 0. Now, this x value is 0, but if I go up, that's going to be 0, 1. And if I go down, that's going to be 0, that's a 0, negative 1. This is making pretty good sense, right? Now, my next goal is to move on and label other points on the unit circle. So let's take a look at maybe what this value would be. Now I'd like to try to figure out what the value of this point is right here. So remember, so far we know 1, 0. Up at the top is 0, 1. To the left is negative 1, 0. Down at the bottom is 0, negative 1. So we know 4 of our many points we've got to find. The next easiest point to work with is this value right here, and then we'll use that to find the point on the circle at 3 pi over 4, and then at 5 pi over 4, and at 7 pi over 4. Now, I've got this line drawn through here to point something out to you, and it's something I know you realize, because this is pi over 4. It is halfway, the angle halfway between. So this is the line y equals x. Now what's significant here is that at this point right here, the x and y value are the same, right? Now that's not true on the circle anywhere else except right here and right here. The x and y values are identical. we need that information to find out what that point is. Now, you know that point's not 1, 1, right? Because 1, 1 is right up here. If you go up 1 and then to the right 1, we're talking right out here. So it's not that. It's some two values that are the same that is less than 1. And remember, what's important is x squared plus y squared equals 1. They add together to give you 1. Now, here's the trick. So I start with the equation. Because remember, any value, x and y, on that circle, make that equation true, because this is the equation of a unit circle. X squared plus y squared equals 1. Now, if x and y are the same, I'm going to substitute for this y and call it x also. So that means x squared plus x squared is equal to 1. Now, we know x squared plus x squared is 2x squared equals 1. And if I solve for x, the next step is to divide both sides by 2, right? And I get x squared equals to 1/2. And then I take the square root of both sides. So if I take the square root of the left and the square root of the right, remember the rule, I have to add plus or minus. And that gives me, change my pen back, that gives me x is equal to plus or minus the square root of 1/2. Now let me simplify that. That's going to equal plus or minus, and then the square root of 1 over the square root of 2. I can do that right. If I have a square root division or fraction, I can take the square root of each of those, which gives me the square root of 1, and we know is 1, and the square root of 2 is that. But then I have to do something I have to do in this class all the time. I need to rationalize the denominator. So if I do that, I multiply by the square root of 2 over the square root of 2. And finally, I get the answer plus or minus the square root of 2 over 2. That is my x value. It's also my y value. Remember, the whole point is that the x and y value is the same at this value right here. Now, we got two answers, though. We got positive square root of 2 over 2 and negative. But we know x is positive right here. So that point is positive square root of 2 over 2 and positive square root of 2 over 2. Well, where does the negative come in? Well, right down here, right? That point is negative square root of 2 over 2, and the y value is negative square root of 2 over 2. Now, how could we use symmetry to label this point also? Now, what we know is the y values are the same right there. They're both positive square root of 2, but the x value is going to be negative. So this point is negative square root of 2 over 2, but the y is positive square root of 2 over 2. And then symmetry here, we know what's going on there. The x is positive, but the y is negative. Okay, so positive square root of 2 over 2 for x and y here. Negative square root of 2 over 2 for x, positive square root of 2 over 2 for y, and this is at the angle 3 pi over 4. At the angle 5 pi over 4, they're both negative square root of 2 over 2. And at the angle 7 pi over 4, we have a positive square root of 2 over 2 and a negative square root of 2 over 2. Now don't worry, in the end I'm going to give you a really nice, clean-looking unit circle with all the information filled in. But I just want you to see why these values are as they are. Now, probably the most challenging to figure out point-wise, mathematically most challenging, is this point pi over 3 right here. So we're going to use what we do in just a minute to evaluate this value at pi over 3, to figure out the value at 2 pi over 3, to also figure out the value at 4 pi over 3, and 5 pi over 3. So this is to handle all the over 3s, which live up at the top here, and then eventually it's going to help me find this one lower left at 4 pi over 3, and this one lower right at 5 pi over 3. And again, we already know this one, right? This point right here is 1, 0. And we know this point over here is negative 1, 0. And we've also learned what pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4 are. Okay, I'm going to leave this page and show you a different page that we're going to work with these ideas. Okay, so what I've got going on right here is the same a visual that I showed you earlier, but without all those angles labeled so it doesn't get in the way of what we're looking at, and some straight lines. And let me talk to you about that in a minute. Now, we know this point right here, again, I just labeled it a minute ago as the point 1, 0. All right, and we know this point over here is negative 1, 0, but I don't need it, so I'm not going to label it. Now, follow along with me. The point that we're looking for is this point right here, and I'm going to call this X and call this point Y. Okay, so we just know that point is X and Y. I don't know the value, I know it's X and Y. Now, do you agree that this point right over here, if that's positive X, positive Y, due to symmetry, this has got to be negative X, positive Y. Why do you say? Well, let's talk about this. This line right here, the distance from 1, 0 to this point right here, okay, is the same as the distance from XY to this point over here, negative XY. How do I know it's the same? Well, remember what I've done is I've taken the top half of the circle and divided up into 3 equal arcs. So you've got first arc, second arc, third arc. Those arcs are all the same length. So we know from geometry that the chords connecting those arcs would also be the same length. If I drew a straight line from this point here to down here, it would also be the same length as these two. I didn't draw that because I don't need it. Not for my calculations. So 2 things you've got to agree with me on. If you don't, hey, send me an email and we'll talk about it. Is that, again, this chord length is the same as this chord length. And the other situation is that we know these are symmetric. So if I call this point X and Y, then on the other side, that's negative X and positive Y. Now, what am I going to do with that? Okay, well, this, we're going to call this line right here D1. Notice I've got it labeled for you. And this line right here, D2. And what I know is that D1 length is equal to D2. That's where we said the chords were equal. Well, what am I doing with that? Well, we know the distance formula. The distance formula is D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, all these are, the x2, x1, and y2, y1 are just points. So when I say the distance between these two, here's my x, one of my x's is x, one of my x's is 1, and then one of my y's is y, and one of my y's is 0. That's for D1. And then D2, when we subtract the x's, I'm doing x and negative x, and y and y. Okay? So let's write down D1. I'm going to do this twice. So D1 is going to be, from my picture, I'm going to, just like it says, subtract the x's and square. So to be x minus 1 squared, and then plus, I'm just using the distance formula, subtract the y's and square. So y minus 0 squared. Now I'm also going to find D2. Okay, so formula says I subtract my x's. So this is going to be x minus negative x squared. You can subtract them in any order you want. You're going to get the same result. And I subtract my y's. Y minus y squared. I'm going to go to another page because I need more room to do the math. Okay, so what I've done here is I've just transferred that information to another page so we can do all the math here. So again, D1, which was the first chord on the far right, and then D2 was the second chord straight across the top. So let's simplify D1. If I have x minus 1 squared, and then that's plus y minus 0 squared, that's the same as saying x minus 1 times x minus 1 plus y squared. And I simplify that. I need to FOIL that out, right? So that's going to give me, if you FOIL that, it's going to be x squared minus 2x plus 1 plus y squared. Now, I left a step out of FOIL, but you know what I mean. X times x is x squared. X times negative 1 is negative x, but then we have another negative x, which gave me negative 2x. And then negative 1 times negative 1 is plus 1 right here, okay? That gave me all of that. Now, watch this trick. X squared plus y squared. Remember, we were dealing with the equation of a circle, and we know that x squared plus y squared equals to 1. I'm going to replace that with 1. So x squared plus y squared is 1 minus 2x plus 1. That's going to give me 1 plus 1, which is 2. So that's 2 minus 2x. That's what we have so far. Now I'm going to go over to the right and simplify d2. That gives me, now here, x minus a negative x, y'all, that's 2x, right? Because the two negatives cancel. And then I have 2x squared. Now 2x squared, well, let me write that first. So that's 2x on the inside, then squared, plus, now over here, y minus y is 0. 0 squared is 0. So I keep going with this. That gives me the square root. Now, 2x all squared, square the 2, that gives me 4, and square the x, that gives me x squared. Now, I can't take the square root of that. The square root of 4x squared is 2x. And since x is positive, where we were looking on the unit circle, I don't have to worry about could that be positive or negative when I take the square root. So now we have this equation right here. The square root of 2 minus 2x equals 2x. I need to solve that equation, and I also need more space to do it. I might could write over here. Forgive me if this turns into a mess, but let's do it small over here. I'm going to do it in black. Now to solve this, the first thing I need to do is get rid of the square root. So you know what? I'm going to square the left side, and I'm going to square the right side. Now that's going to give me 2 minus 2x on the left, and 4x squared on the right. This is a quadratic equation. I need to solve it. To solve a quadratic equation, you get it equal to 0. So I'm going to move the minus 2x and the plus 2 to the other side. That gives me 0 equals 4x squared plus 2x minus 2. Now, can I factor this? Well, I can certainly factor out a 2. Okay, that gives me 2 times 2x squared plus x minus 1. I'm probably going to need more room to do that. I've got this stray value up here because my pen is not working efficiently anymore. 2x squared. There we go. Now, you can either attempt to factor this. I need values that multiply to be negative 2 and add to be 1, and they do exist. Or you can throw it into the quadratic formula. Or some of you just may see that that factor is using trial and error. So I have 0 equals 2 out front. And then this first factor, you could say, is 2x minus 1. And then the second factor would be x plus 1. If you don't believe me, just multiply that back out, and you would see 2x times x is 2x squared. 2x times 1 is 2x minus x gives me this value. Negative 1 times 1 is negative 1. Now, in a different color, because I just don't want to change the screen, I want you to see this finished. If I let each of these factors equal 0, I can't set 2 equals 0. It's completely gone. If I set 2x minus 1 equal to 0, that's going to give me x is equal to 1/2. That is one of my solutions. If I set x plus 1 equal to 0, it's going to give me x is equal to negative 1. That's another one of my solutions. Keep those two values in mind. X equals 1/2 and x equals to negative 1. Now here I'm back at my picture. If x equals to 1/2 is one of my values, and x equals to negative 1 is another possibility for x. Remember, we were finding this point right here. Y'all, x equals negative 1 is right over here. That actually gives you that point. Kind of makes sense. because that is the other chord. But x equals -1 is not the answer that we're looking for right now. It's x equals 1/2. So I know my x value is 1/2. Well, how do I find my y value? Well, you know how to find your y value, right? We're working with the equation x squared plus y squared equals 1. And we just solve that equation by plugging in 1/2. So 1/2 squared is 1/4. Oh, my pen has gotten just so bad. Hang with me. That's 1/4 plus y squared equals 1. To solve that, I'm going to subtract the 1/4 over. That's going to give me y squared equals, now 1 minus 1/4 is 3/4. You know that, right? It's really 4/4 minus 1/4. I take the square root of both sides, and I get plus or minus the square root of 3/4, which gives me plus or minus the square root of 3/2. I took the square root of each part, and that is my y value. Now, the -1 doesn't apply because we're in the first quadrant up here. X's are positive, y's are positive, so that gives me the square root of 3/2. And that will help us complete every value on the unit circle, and I'll show you that. So we're here at our almost completed unit circle. So in red, let me remind you, the quadrantal angles are points of the angles are 1, 0, 0, 1 for up at the top at pi/2. At pi to the left, we have -1, 0, and at the bottom at 3 pi/2, we have 0, -1. The next thing we did was prove the pi/4 values. Remember where x and y were the same? And that's how we did our proof. So we have square root of 2/2 for x and square root of 2/2 for y at pi/4. Then in quadrant 2 at 3 pi/4, the x is negative square root of 2/2, but the y is still positive. At 5 pi/4 in quadrant 3, both those values are negative because that's quadrant 3. X and y are negative square root of 2/2 and negative square root of 2/2. And then quadrant 4, we have 7 pi/4 where x is positive square root of 2/2 and y is negative square root of 2/2. Now, the last one that we just proved was that we found x was 1/2. We did a lot of work to find x is 1/2. We plugged that back into our unit circle, x squared plus y squared equals 1, to find out that y is square root of 3/2. So at our pi/3, x is positive 1/2, y is positive square root of 3/2, and then we use symmetry to work on 2 pi/3 in quadrant 2 in the green, where x is negative 1/2 and y is positive square root of 3/2. Then down here in quadrant 4, 4 pi/3 has x is negative 1/2 and y is negative square root of 3/2. Because remember, both values are negative in quadrant 3. And then in quadrant 4, my x should be positive 1/2 and my y is negative square root of 3/2. So I had an error right there on that one, but I just fixed it. So again, x is positive 1/2, y is negative square root of 3/2. Now to wrap this up, notice we still have 4 missing values, and that is pi/6. Now you're going to have to trust me on this, but we could prove that the values for pi/6 are inverted for the values of pi/3. Instead of 1/2 for x and square root of 3/2 is y, that gives me square root of 3/2. You can't read my writing, for x, and 1/2 for y, but that's square root of 3/2. Now, where does that come from? Well, the proof for that, and I'm going to kind of write you a quick picture over here in the bottom right corner, would come from a similar idea where you're looking at pi/6 here, 11 pi/6 here, and this point up at the top, which is 0, 1. And once again, we draw a chord from 0, 1 to this value x, y that we don't know. And then we draw a chord here from x, y down here to x, negative y. and the fact that the distance of this chord is the same as the distance of this chord would solve almost just like the math we did earlier to find out that, again, my x is square root of 3 over 2 and my y is 1/2. And we use that symmetry to finish this out. So over here on the left at 5 pi over 6, my x is negative square root of 3 over 2 and my y value is 1/2. And then at 7 pi over 6, my x is negative square root of 3 over 2 and my y is negative 1/2. And to wrap it up at 11 pi over 6, my x is positive square root of 3 over 2, and my y is negative 1/2. And that completes our unit circle. I'm going to show you another diagram of this where it's all written out very nicely, and I will post a copy of this as well. And here it is. So this is the completed unit circle. You do need to know all of this. I know it's a lot of memorization, but I promise you, if you take the time to learn this, this includes every angle, how to change it to degrees, and every x, y value at every angle on the circle. You will do well in trig. You need to know this information first. So I'm going to quickly recap the entire unit circle. Like, you have to fill it out from scratch, okay? So first I would do the angles. And when you do the angle, again, you start at 0. You know, all the way around is 2 pi. Okay? And then you count your over 4s, which are the guys in the middle and straight up and down. So I have pi over 4. This is 2 pi over 4, which reduces to pi over 2. This is 3 pi over 4. Over here we have 4 pi over 4, which reduces to pi. Then I have 5 pi over 4. Okay, this is 6 pi over 4, which reduces to 3 pi over 2. This is 7 pi over 4. Okay, and I meant to put, well, it's all right. Now, I'm going to do the over 6s, and this will take care of everything. But what I want you to remember is that when you count your over 6s, you leave out your pi over 4. I'm going to circle it. 3 pi over 4, 5 pi over 4, 7 pi over 4. You leave those out. So I've got 0 pi over 6. This is 1 pi over 6. I'm not going to put the 1 there. This is 2 pi over 6, which reduces to pi over 3. Straight up and down is 3 pi over 6. It counts. It reduces to pi over 2. And then you have 4 pi over 6, which reduces to 2 pi over 3. Skip the over 4. 5 pi over 6. 6 pi over 6, which is pi. 7 pi over 6. 8 pi over 6, which reduces to 4 pi over 3. 9 pi over 6, we've already got written up. 3 pi over 2. 10 pi over 6, which is 5 pi over 3, and 11 pi over 6. Of course, if we count here, that's 12 pi over 6, which is 2 pi. And look, there's all your angles. All you have to know is your over 4s and your over 6s, and then reduce fractions. Now your points. So watch this trick. We know this point right here is the point 1, 0, but I have a trick for you to do the y values. So the y values all the way up to the top. Okay, so when you do a y value, you count square root of your number, you're just counting, over 2. What do I mean by that? This would be the square root of 0 over 2. This is the square root of 1 over 2. Now y'all know the square root of 1 is just 1, so that's really 1 over 2. This is the square root of 2 over 2. This is the square root of 3 over 2. This one is even the square root of 4 over 2. Now what's the square root of 4? It's 2. 2 over 2 gives you 1. So isn't that neat? You just count up, but you just got to remember it's the y values, and it's the square root of the number, your counting number, over 2. Now, to do the x values, you just go backwards. You switch everything. So this is the square root of 0 over 2, which is 0. This is the square root of 1 over 2, which is 1/2. This is the square root of 2 over 2. This is the square root of 3 over 2. And this is the square root of 4 over 2, which reduces to 1. And then symmetry gives you the rest of them. Remember, x's are negative over here. X's, oh my goodness. My screen magically zoomed, and I hate it when it does that. I promise you it's not me doing it. It's some weird thing with the pen app. But anyway, what I was going to say, over here, the x values are negative. Oh, there went the zoom again. Maybe it'll go back. I know how to get it back now, which is good. I think what happens is my pen just disappears, and then all it does is zoom. All right, so x's over here are negative. Y's over here are positive. And then symmetry is the same. So, for example, pi over 3 and 2 pi over 3 are the same values, except x's are negative and y's are positive. And I know you see that symmetry. Same thing as pi over 6 and 5 pi over 6, except x's are negative and y's are positive. Down here in quadrant 3, we know that x's are negative and y's are negative. So every point value down here is negative. And again, it's just symmetric. The over 6 values are the same as these over 6 values, but negative. All right, and then over here, x's are positive, but y's are negative. Okay, and again, symmetrically, over 6's are the same. So you have a positive square root of 3 over 2, but a negative 1/2. So this is the same down here, but x's are positive, y's are negative. So again, and that's the fast way to do it, y'all. Now, you might have your own methods, and I'm totally good with that. But honestly, that's the fastest way to learn this unit circle. And you got to know it. You got to know it. All right, I hope you have a good day. I'm going to come back for part 2 for the second part of section 4.2, which is defining the trig functions and then identities for the trig functions.